Welcome Graph Fire pupils to the next video on the straight line topic, and this time we look at the first of our three special lines. Okay, and this is what we call a perpendicular bisector. A perpendicular bisector is a line that cuts to the midpoint at right angles. It's self-explanatory in the sense we have perpendicular at right angles, and bisect means cut exactly in two, and therefore cuts through a midpoint. Okay, this can occur within a triangle. In the ABC triangle, we have the perpendicular bisector DE is cutting at right angles, as we can see, and bisects, cuts exactly through the middle of AB. With our second example, we have the line AB, and again cuts at right angles and exactly through the middle of AB. Our method, we'll try and keep as close as possible to our point gradient equation. First of all, we find our midpoint of our bisected line. That allows us a point that our perpendicular bisector goes through. We then find the gradient of the line, and then we use that to find the perpendicular gradient, and that allows us to then find our equation. So looking at an example, find the equation of the perpendicular bisector AB given the 2 points A and B. Ultimately, this is the equation of our line. So what we're aiming to do, as any other time, is use our formula y minus b equals mx minus a, where we need a point that the line goes through, and we need a gradient. Again, trying to follow point gradient equation. Our point we do not have, and we're going to look to try and find our midpoint of the points AB. So if we're looking to try and find our midpoint, we use our midpoint formula. Here we have our two x values added up and divided by 2, so work out our average, and our two y values added up divided by 2 to work out our average. So here we have our x and y of our first, and our x and y of our second. Again, marking our values to try and keep as accurate as possible. Minus 1 plus 7 all over 2, and minus 2 plus 2 all over 2. 6 over 2, 0 over 2, gives our midpoint of 3, 0. Therefore, we have our point. For our gradient, first of all, we have to work out our gradient of AB, given the 2 points that we've got, using our gradient formula. Points are marked accordingly. 2 minus minus 2 over 7 minus minus 1, 4 over 8 is equal to a half. So this gives us the gradient of AB. However, we're looking for a perpendicular gradient. for MAB times by perpendicular to equal to -1, our perpendicular gradient must equal 2, our negative reciprocal, so -2/1, which is equal to -2. Flip it and make it negative. That gives us the gradient of the line perpendicular to AB, therefore the gradient of our perpendicular bisector. We now have the point, the gradient, and now we can work out our equation. Y minus 0 is equal to -2 x minus 3. Y is equal to -2 x plus 6, given our equation. Example 2, this time within a triangle. If we do a very quick sketch, just to give us a wee hint. -5, -2, 13, 4, -2, 6. This is a rough idea of what we're looking for. Where we have x, y, and z. And we are looking for the perpendicular bisector of xy. So we are looking for the line that goes through the line xy straight through the middle. So once again, we treat it as an equation of a line. So we want to try and find, want to use y minus b equals m x minus a. And we're looking for a point. And we're looking for a gradient. Our midpoint of xy is our x values added divided by 2, our y values added and divided by 2. Careful to use the correct points. So we're using x and y. There's x and y of our first. X and y of our second. -5 plus 13 all over 2. -2 plus 4 all over 2. So we have 8 over 2, 2 over 2, which is 0.41. And our gradient so in this first instance we want our gradient of xy to then be able to work out the perpendicular. So the gradient of xy, again using our gradient formula, four minus 2 over 13 minus 5. 6 over 18 is a gradient of a third. So for the gradient of xy times by the perpendicular gradient to equal to -1, our perpendicular gradient in this case would be 1/3 becomes -3 over 1, or if you want straight away to -3. So looking over to our equation, we have a point which our perpendicular bisector goes through, which is 4, 1. And we have the gradient of the perpendicular line. So using our points A, B, let y minus 1 is equal to -3 x minus 4, y minus 1, -3x plus 12. If I add 1 to both sides, y must equal to -3x plus 13. A quick additional fact is within a triangle, the point where 3 perpendicular bisectors meet is called a circumcenter. Okay, our task is within the PowerPoint.